Okay, last part of the statistics chapter now. I'm going to fit it in here just because it makes sense before leaving the chapter, just to get this part done. So this is on page 406 of your textbook, okay, and it's the shape of distributions. Okay, so there's 3 types. Okay, so it's basically when we're looking at these histograms. Okay, so these histograms are like bar charts, except that they have no gaps in between them. So they'd be used for continuous data like measuring or weight. Okay, anything that should be measuring distance, time. Whereas bar charts are used for discrete data where you're counting. Anyway, so we have our histograms here, and sometimes we can see a pattern in the shape that the histograms make. Okay, so we have to be able to identify 3 different types of patterns. Okay, the first one is symmetrical, where you can see there here that this histogram is making a symmetrical shape. Okay, and we also call that the normal distribution. The second one then is where it increases very steep at the start and then it gently decreases. So that's called a positive skew, or skew to the left. And then we have a negative skew where the incline is gentle at the start and then it's really steep when it comes back down. Okay, which is skewed to the right. Okay, so we have to be able to recognize these and know which sort of situations will react what way. Okay, so we're going to go back to the first one. So anything that I've written in and highlighted is what I want you to copy into your notes copy. Okay, so the first one, there's symmetrical distribution. Okay, so you can see there the line of symmetry will be down the middle. Okay, and that's also called a normal distribution, so you need to know that. Okay, there's a whole chapter to come next year based on this normal distribution shape. Okay, so normal distribution, I suppose the one that we're looking at all the time in the moment and the news is the COVID-19. Okay, other examples of it would be your Leaving Cert results. Okay, so if you think of the government, even with these predictive grades that they're saying that we're to give students now, they'll still have to make this sort of normal distribution shape. Okay, that means that there'll be this number of, I can't say A's, I suppose H1s we're talking about now. So we'll say this will be the H1s, H2s, H3s, okay? They want the majority of people then to be in the H4, H5, and then again H6, H7, people who don't pass it would be very small. Okay, so this is the shape that they always make it fit into, unfortunately. Okay, so if there's too many H1s, then they're going to change the question to make it a bit more difficult in terms of how they mark it. Okay, so it has to, Leaving Cert results have to fit into this shape as well before they give out results. Okay, so you'd have your H1s are very rare, H1, H2, there'll be less of. Over here in this extreme again, your H7, H8, okay, are less, not as many, and then you have your H4, H5, H6s would be kind of towards the top. Okay, so that's 2 examples there when you're drawing it in. So you have your coronavirus is making this shape in terms of the number of cases, and your Leaving Cert results there as well. Okay, 2 more examples I've taken there. Heights of random people. Okay, so I suppose if you take heights of female adults in Ireland, okay, I suppose the majority of people are between, I don't know, 5 and 6 foot tall. Okay, you'd have very few people then less than 5 foot, and again greater than 6 foot. Okay, the majority of people are between 5 and 6, and they'll be broken up like that. Okay, IQs again. Okay, people's IQs, most people are kind of an average IQ, I suppose, be around here. Then smaller IQ, higher IQ. Okay, so then you have your, where would the mean, median and mode fall? Well, actually the 3 of them will actually all be equal in a normal distribution. Okay, so the 3 of them will be the exact same value. Okay, so make sure to draw that in. They'd all be of equal value in a normal distribution. Okay, over to positive skew, or skew to the left. Why do we say it's skewed to the left? Because the most of the data is going to be to the left. Okay, everything to the right over here is much of less value. Okay, you need to know where these 3 fall. Okay, the easiest way that I remember it myself is that the mode is the highest value. Okay, the mode is the most common, so that'll be up to the highest. The median then is next because the median is the middle. So the median is the middle of the mode and the mean. Okay, so that's how I learn it. Mode is the highest, median's in the middle. Okay, and you do need to know where they fall. Okay, and positive skew to the left, you need to know that as well. That's as important as the positive part. Okay, real life examples. So number of children in a family. Okay, so again, you might have family might have one child, two children, 3, 4, 5, and the bigger the family, there's less of those families. Okay, there's less big families than there are families of 1 or 2 children. Okay, the age at which people learn to ride a bike. So again, most people learn when they're a child, but then you do have adults, they're just not as many. Okay, the age at which people marry. Okay, so this would have, so probably after changing a bit slightly, but still most people marry when they're younger, and then you have less people marrying when they get older. Okay,